from, and this is one of the things people lose. Because they don't know where to get the decantate for procedure 9. What we did was 8. And we did the H2SO4. And we got lead 2 sulfate. And we continued with the confirmatory test for lead. So what we're going to do is look at procedure 8 here, because this is what people miss. It says add the sulfuric acid, dense white fumes, turn the page, and this is a turn 2 pages or something, get to the wrong procedure. But at the top of it, it says continuing on down here, white precipitate, I'm about 3/4 of the way down the paragraph. Fine suspension shows the presence of lead. Centrifuge, decant the supernatant, decant until the supernatant is clear, you always do that at a centrifuge. Decant into the test tube and save for procedure 9. So it's hidden here almost at the end of the procedure 8. And people always miss that, and then they get to procedure 9 and they say, what should I use? And they can't find the test tube that they need. So make sure you note that where it says, it's down about the 7th or 8th line, I'm not counting too carefully. Save the decantate for procedure 9, goes on to tell you what to do with the precipitate. So in procedure 9 now, you have the decantate from 8, and you're adding 15 molar ammonia. This is that white precipitate I already talked about. I even wrote a net ionic equation. I said it's difficult to see because up till now, whenever you added something, you made a precipitate, the whole test tube turned cloudy. Now it might turn hazy, or it might be so, if you have a small amount of that bismuth hydroxide, you might not even notice the haziness. So I said, and you're not going to see a precipitate form like you have previously. You always centrifuge it and look in the corner of your test tube for some little gelatinous lump of material. That's your precipitate of bismuth 3 hydroxide. Okay. The confirmatory test then, centrifuge decant, save the decantate for procedure 10. And it's going to break down, so this is the one I want to read to you carefully. But let's finish this one out because this is about where I left off. Wash the precipitate, hot water. To the washed precipitate, you add sodium hydroxide. It says 8 molar. There's only 1 bottle of sodium hydroxide back there. That's the sodium hydroxide you use. It is 8 molar. Okay? People always wonder what the reagents are. First of all, those things get obliterated. I try to write things on. I'm printing up new labels. I'll get some of those on, but they disappear in a week or 2 after people use it and dribble things down the side. So anytime you're in doubt, either ask me. And also I put lists of the different reagents, the acids and bases, on those backsplashes. So I put the concentration, the formula, the name. And with the exception of 3 molar nitric, 3 molar sulfuric, they all have different concentrations. So if you see the concentration, that matches. The other thing I do to help, which doesn't matter because people mix them up anyhow, I put the bases on one side of the sink and the acids on the other, for both sinks back there. When I'm finishing up at the end of the day, I find all the acids in the middle somewhere, and some of the bases here and some of the bases there. That's your worry. If you put them back where you find them, they might be easy to find. Plus, I find all the bottles mixed up and sitting around in different places. One of the things I did was segregated out the 8 ion bottles that you use for preparing your Nonin. I set them on the side of this bench. So I don't care if you mix them up, that's your problem. I start you off right, you can mix it up as much as you want. Okay. So coming back to this thing, You make the bismuth 3 hydroxide. It says add 8 molar NaOH. You want it very basic. And then you're going to add the tin 2 chloride. Now there's a bottle of tin 2 chloride in that set of 8 things that I put to the side to make up your unknown, or make up your known. So you can find it there on the other reagent bench. It's under tin 2 chloride, I guess. The thing I pointed out about the tin 2 chloride, I also mentioned this way back when you did the mercury test. Don't suck up the little pellets of tin in there. And if it's all white and cloudy, something broke down and you want me to refill the bottle with fresh reagent. Okay. So what's going to happen here, we have bismuth 3 hydroxide. That's a precipitate, gelatinous one. You're adding sodium hydroxide. It makes square bracket because it's complex, 2 minus. It makes the tetrahydroxostanate 2 ion. Okay? Can't read it, I just wrote it to you. Wrote it for you. 4 hydroxide and 10, the whole thing has a -2. If you don't add enough sodium hydroxide, only 2 of these will react with this to make tin 2 hydroxide, which is a white precipitate. So what do you do to take care of that? Add some more sodium hydroxide. So you get the complex ion form. So he says 8 drops, that's usually sufficient, but because you're working with a basic solution already. But if you see white precipitate, just add some more sodium hydroxide. This is going to react with, and he has the equation in your book. I just like to write equations sometimes, so I can show you what happens. This goes to metallic bismuth. Okay. That's a redox equation. It's a 3 electron change. This thing goes to subscript 6, 2 minus, the hexahydroxostanate 4. 2 electron change, 3 electron change, lowest common multiple, 6. So you have 2, 3, 3. What did I do? I put my 3 in too soon. So it's 2, 2, 3, 3. Now we got it. Notice you have 18 hydroxides here. You have 12 plus 6 hydroxides. It's all balanced. Look at all those complex ions. What fun. Okay, that's a jet black precipitate. If you have white or gray, try a little more sodium hydroxide. Yes?
You said 8 drops of paper on any oxygen, 3, 6, 3.
Whatever it says. Maybe I wasn't reading. Oh, I read 8 molar. Okay, yeah, just start with 3. You probably want to add a little more than that, but you'll find out because you'll get the white precipitate, and then you'll add more sodium hydroxide to get rid of it. Yeah, 8 wouldn't hurt, but let's save reagents, so let's start with 3. I don't have to fill the bottle as often. And if it makes the white precipitate, add a couple more drops. Okay, so that's your confirmatory test for bismuth, and it really is black. Should not be white or gray. It just means that you're probably getting tin 2 hydroxide. Now comes the important step here. I'm going to procedure 10. And it's really confusing because his formatting, he has some things indented and other things not indented, and you can't tell which thing goes with which. So, part A and part B, this is procedure 10 on page 189. I'm going to do this. Divide the solution into half. He says take 10 drops, okay? Because he's assuming you got to that point with 20 drops. Okay. So he says 5 drops. He assumed you got there with 10 drops. But remember, way back here I said you can't add too much ammonia. Some people add 15, 20, 30 drops of ammonia because they want to be sure. So the simplest thing, so things will always be consistent, rather than taking 5 drops like he says, you just divide this solution into half. One part is for 10A, and then the other part, which is the copper detection, and the other part is for 10B.
And that's the decantate from 9, right?
That's
You're
the
splitting
decantate
it.
from 9. So just where it says 5 drops, to divide in half. And then he goes through a rationale, I'll come back to it. But this test, the blue color already is a pretty sensitive test. In other words, you get the dark blue if you get when you make the tetramine complex for the copper. But if you have a trace, you might not notice it so much. So this test is even more sensitive for copper than the blue color. So you're dividing in half, then you're going to acidify. So it says add 5 molar acetic acid. Now the tricky word here says decolorize. You started with this is the deep blue color. When you make it acidic, this goes to the ammonium ion, so it breaks down the complex, so you get copper. This is, what should I say? This is blue. You can't read this because I made it really small. That's pale blue. So it doesn't get colorless, which is what people would think when it says decolorize. Okay? So it just goes from a darker blue to a lighter blue. That's what he means by decolorize. That tells you you added enough acetic acid. What would be another way of deciding if you added enough acetic acid? Yeah, use litmus paper. And when you do your unknown, chances are you won't have copper in your sample, so you won't have a blue color to see the change. So the other thing is, you use test acid with litmus. So essentially that breaks down the complex when you make it acidic, converts the ammonia to the ammonium ion, acid-base reaction. And now in that solution, you're going to have both of these, copper ion and cadmium ion. And he says add, and people come running around and say, I can't find that. What the heck is it? It says 0.2 molar K4 FeCN6. That's potassium. Oh, let me write it. Potassium hexacyanoferrate 2.
Is that a 4 subscript?
This is a 4, yes.
Look like a Y for a second.
There, now it looks even worse.
No, it looks
It's a 4. Okay. People confuse this with what we're going to use in this part, which is potassium cyanide, which is the dangerous stuff. This is out in the laboratory, so it can't be too dangerous. It doesn't make much cyanide. You might do a calculation for that later on. But in the old days, notice I always refer to the old days, when you used to be able to go to the toy store and buy a set of chemicals for the kids and everything. Now you go to the toy store and buy a set of chemicals, the chemistry kits for the kids, and they have sodium chloride and water in it. In the old days, they used to put this sort of thing in there because it was relatively harmless, but I guess some kid figured out how to poison themselves with it. So now they don't put that in.